during this presentation over atoms, make sure to use your Cornell notes that you received in class to take notes over everything that we are about to talk about in this presentation. In the notes section, take notes that in detail about information that you may see on the screen or hear me talking about. In the section to the left, you're going to put your main ideas that may be in keywords or pictures. And then when we're done with our presentation at the end, put your summary at the bottom of the paper where it says summary. Now, thinking about what we talked about in class previously, you know that all matter is made of atoms, and atoms are the smallest particle or smallest part of all elements. And inside an atom are actually smaller particles called subatomic particles, and sub meaning under. So these smaller particles are that make up the atom are called protons, neutrons, and electrons. And we're going to talk about each of those separately. Now, the first subatomic particle we're going to talk about is a proton. Now, the proton is located in the nucleus, and the nucleus is the center of the atom. Now, these protons have what are a positive charge, and the protons are the only elements, subatomic elements in the atom that have a positive charge. Again, these are located inside the nucleus of the atom. The second subatomic particle we're going to talk about is the neutron, and the neutron, is like the proton, is also located inside the nucleus of the atom, in the center of the atom. It is a neutrally charged particle, so it has no charge at all, zero. Compared to the other two, this is the only one without a charge. Now, the last of the three is called an electron. Now, the electron is not located in the nucleus. It's actually located outside the nucleus in what we call the electron cloud. Now, the electron has a negative charge compared to the other two. Again, the electron is found in the electron cloud. Now, the protons and the neutrons are larger than the electron. To give you an example, the protons and neutrons might be the size of, say, a golf ball. Compared to the protons and neutrons size, the electron, compared to the golf ball, would be about the size of a grain of salt. So much, much smaller in size than the protons and the neutrons. Now, electrons are found on what are called energy levels or electron shells. And these shells are located outside the nucleus in the electron cloud. And they hold a certain number of electrons in each shell. Once the amount of the electrons is reached the maximum number that can be held in that shell or that energy level, then we will add another energy level or electron shell to add the remaining electrons. So once those energy levels are filled up, then we move on to the next one. So each energy level, like I said, holds a certain amount. The first energy level can only hold 2 electrons. The second holds 8, and the third holds 18. For example, let's take the element oxygen. Oxygen has 8 electrons. So the first energy level is going to hold 2 electrons. It can't hold any more than 2. So there's no way to put more than 2 electrons in that first energy or electron shell. So that leaves us with 6 electrons, because 8 minus 2 is 6. So now we put the remaining electrons on the second electron shell. So we put 6 out there. So remember, the second one can hold 8. So we have plenty of room to add 2 more if we need to later on for another element. But at this point, we have 2 in the first, and then 6 in the second electron shell. And remember, they have to be full. The first one has to have 2 before it can go to we can add another shell. So this is an example. This is a Bohr model, and this is a Bohr model of oxygen. As you can see in the first energy level, which is the light blue level closest to the yellow, that has 2 electrons. Then when we go out to the outer electron shell, we can see that we put the remaining 6 there because we had 6 left over. Another area of information that we need to get about the atom is the mass of the atom. The mass of the atom is only located in the atom, or the nucleus of the atom. Protons and neutrons have a mass of about 1 AMU, and AMU is an atomic mass unit. Electrons have a mass that is much, much smaller. The neutron's mass is about 1 AMU. Proton is about 0.99862,349, which is just a little bit underneath 1. But if you look at the electron, you're looking at about the 100,000th place below 1. So we're looking at a very small mass. So the mass is so small that we don't even take it into account because it really doesn't affect the mass of the atom to begin with. So the only two subatomic particles that we take into consideration for the mass of the atom are the protons and the neutrons, and they're both located in the nucleus. So when we say where is the mass of the atom located, the mass is located in the nucleus because that's where the protons and neutrons are located. Now some of you may be asking, how do I know how many protons, neutrons, and electrons are in each element? Well, that's what we're going to talk about next. So to find the number of protons, electrons, and neutrons, we're going to use these following steps to find those numbers. The first thing we need to do is look at our periodic table. The periodic table has information about each element, such as this atomic number, which is the atomic number of hydrogen is 1, and its atomic mass, which is 1.008. So we need to know both of these numbers. So we need to know the atomic number and the atomic mass. Now, with the atomic mass, we usually round up or round down to the nearest whole number. So now that we know the atomic number, knowing the atomic number, we automatically know how many protons there are. So in the hydrogen, there was only the atomic number was 1, so that tells us there is 1 proton. So the atomic number equals the number of protons. So they're the exact same number. If you add or subtract a proton, then you're going to change the entire element. So if I added another proton and now I have 2 protons, now I have helium, because helium has an atomic number of 2, meaning there are 2 protons in that element. Now, atoms are a neutral, or have a neutral charge, meaning they have no charge. So there has to be a balance. If we just have 1 proton and that's it, then we have a positive charge of the atom, because protons are positive. But we have to balance that out. So we have to come in and bring something in that will kind of cancel out that positive charge. And what we do is we bring in an electron. So the electrons and the proton numbers have to be exactly the same. So if you know the proton is 1, then the electron is also going to be 1 as well. So the atomic number, which is 1, tells us both the protons and the electron number. Because remember, the number of protons and electrons have to be the same, so they cancel each other out to make the atom neutral. Okay, so we know how to find the number of electrons, and we know how to find the number of protons. So what's left is the neutrons. So to find the number of neutrons, what we have to do is now we have to take into account the atomic mass. So what we do is we round the atomic mass to the nearest whole number. So in this example, 4.65 or 14.65 is rounded up to 15. So we take that number and we take into consideration the proton number, and so that's the atomic number and the atomic mass, and we subtract the two. When you subtract those two, you get the number of neutrons. One way in which we can remember how to figure out how many protons, electrons, and neutrons there are in an atom or an element by using the periodic table is what we call APE-Man. And what APE-Man is APE, APE, means the atomic number is equal to the protons, which is also equal to the electrons. So APE, atomic number, protons, electrons. And so the man part is when we come into the atomic mass minus the atomic number equals the neutrons. So we have APE, which tells us how many protons and electrons there are by using the atomic number. And then we have man, which is using the mass, atomic number, subtracting those two and getting the number of neutrons. Again, here's an example. We use the atomic mass minus atomic number equals neutrons for man.